Frequency distribution, we have seen, even in case of discrete probability distribution, we have seen we want to find the value of x lying between two values, x1 and x2. That is probability lying between 0.2 and 0.3. We have seen this. So how to go like this here? So what we do is, this becomes sigma root 2 over pi x1 to x2 e to the power minus x minus mu square by 2 sigma square dx. This is the probability of x lying between x1 and x2. Now we had defined that x was x minus np by root over npq. This is what? X minus mu by npq is sigma. So if we take dz by dx, what you will get? Simply 1 by sigma. So putting this in this, what we get? So let's say our z1 is this and z2 is this. Then we can write this function, this integration, as 1 by simply root over 2 pi, because dz was dx by sigma. So dx by sigma becomes dz. This becomes z1 to z2, and this is e to the power minus z square by 2 dz. Clear? Now this can be written as 1 by 2 pi 0 to z2 dz minus 1 by root over 2 pi 0 to z1 e to the power minus z square by 2 dz. Clear? Now the function is written as pz, this function, 1 by root over 2 pi 0 to z e to the power minus z square by 2 dz. So this function is called pz, which is called probability integral or error integral, error function. So it is written like this: p2z minus p1z. p2 means 0 to z2 and p1 is 0 to z1. The values is given in, the value of this integral is given in almost all the engineering books or advanced mathematics books. You can find it in the annexes. That is called area under the normal curve. Area under the normal curve, where you will find the values of this pz. So you can, if you have this question, you will see the value of z from 0 to z2 and then 0 to z1, and by taking the difference you will find the probability. Clear? We will solve examples to understand this. Now we just saw error function. Probable error is lambda, where x minus lambda, let's say this is the point lambda, then x minus lambda to x plus lambda is such that the probability of error lying within this, that is the area under these 2 points, is equal to the area under these 2 points. Okay, so this area is half of the total area. That is the meaning. So how we get it? So the meaning is, we have sigma root over 2 pi integral mu minus lambda to mu plus lambda. This is e minus x minus mu square by 2 sigma square dx. So this is equal to half. Total, if you integrate it from minus infinity to infinity, this will be 1, because this is the probability function. Therefore half of it is this. So if you equate this out, we will get the value of lambda. From here, putting the values, we will get the value of lambda, and the value you get is, that is 0.6745 of the standard deviation. So what we saw is that the probable error is 0.6745 sigma, that is approximately equal to 2 by 3 of sigma. Now we know that quartile deviation is what? Half of Q3 minus Q1, that is the third quartile minus first quartile. This is the formula for this. Quartile deviation for a normal distribution is approximately equal to this value only, 2 by 3 of sigma, that is sigma is standard deviation. Another very useful and very handy formula is a ratio that quartile deviation is to mean deviation is to standard deviation. This is equal to 10 is to 12 is to 15. So this you should keep in mind. This is very useful. Now I am presenting a very interesting topic. This is x1, this is x2, this is the probability. We know this is at x equal to mu. At x equal to mu, we have the mode, the highest point. Now this says that from mu minus sigma to mu plus sigma, this from here to here, if you take this part, that is mu minus sigma to mu plus sigma, it is the probability is 0.6826. It means it is about 68% of the total area. If you take from minus infinity to infinity, that curve y dx, then this will be about 60%, 68%. That is mu minus sigma to mu plus sigma. You will find questions where you will be given that the probability between this and this is this. Find sigma or find mu, something like that. One variable will be given and you will have to find the second one. So remember this, mu minus sigma to mu plus sigma, probability is 0.6826, that is 68% area. Clear? Second, mu minus 2 sigma to mu minus 2 this sigma, this minus 2 sigma to plus 2 sigma. If you take up to this point, see this whole area, it is the probability is 0.9544, that is 95.5% approximately. So this area is approximately 95.5%, that is from mean minus 2 of standard deviation to mu plus 2 of standard deviation. The probability, if you add up the probability, if you integrate from this to this, probability is this. Similarly, from mu minus 3 sigma to mu plus 3 sigma up to this point, this is the probability is 0.9973 or 99.7. See, this is mu, this is sigma. I have written these in red because this is not with reference to origin. This is from mu to minus sigma, mu to minus 2 sigma. So I have written them in red. So don't get confused that sigma means here to here. This is not x equal to sigma. If you put here x is equal to mu plus sigma, here x is equal to mu minus sigma. Clear? Similarly, these are some other interesting data. See, if you take mu minus 1.96 sigma to mu plus 1.96 sigma, the probability will be 0.95, that is 95% of the area curve. Then minus 2.58 to 2.58 sigma, it is almost 99%. Probability is approximately 99%. Then mu minus 3.29 to plus 3.29, it is 99.9%. So these are some interesting figures that you should keep in mind. You may find it very handy while solving objective questions. So you should keep this in mind. On similar terms, if in place of x1, x2 you take z1, z2, and what was z was x minus mu by sigma, that is x minus np by under root npq. So if you take z, then if z1 to z2, we take minus 0.745 to plus 0.745, it is the probability is 0.5, that is approximately 50%. And minus 2.58 to plus 2.58, it is 0.99, that is 99%. So these are also some very interesting figures. You should keep them in mind.